So I set you a few questions on maximum and minimum values of waves and wave equations. What I'm going to do is work these through with you, show you the solutions and show you how we'd approach a question like this. So a quick refresher for you, these were the two questions I set. So the first one was just simply taking a trig equation, 15 sin theta minus 5 cos theta, and using our wave version of that to figure out the maximum and minimum values. And the second one was nearly the same, finding a wave version of this equation but then using it within a bigger equation to look at maximum and minimum values there. So let's have a ping at these. First one using the form r cos theta minus alpha, where r is bigger than 0 and alpha is between 0 and 2 pi. What is the maximum and minimum values of this? So to get the maximum and minimum values of this, because we've got two mixed trig equations, the very first thing we have to do is turn it into one and turn it into this form here. And again, we start this the same sort of way. So r cos of theta minus alpha, we expand it using the wave equation. So we'd expand that to r cos alpha cos theta plus r sin alpha sin theta. And we know that we can equate that to this one here. Now, when we're equating it, we start by looking at the coefficients. So in this case, it would be the 5 and the negative 15 and equating them over here. So the 15, we know that's going to be the r sin alpha because that's the sin theta coefficient there. And we know the negative 5 is going to be the r cos alpha. And from this, we then get tan alpha. So tan sin over cos, so it's 15 over negative 5, which in this case is negative 3. We then jump in with our cast diagram and we see where the angle we're after lies. So sin's positive, there and there. Cos is negative, there and there. And tan is negative, there and there. It's in this quadrant here. So whatever we got when we took tan minus 1 of negative 3, we subtract it from 180 degrees, or pi in this case, because we're working in radians. So we know we're after alpha equals tan minus 1 of negative 3, using that bit of equipment there. What we end up getting in terms of radians is that alpha equals 1.89. So alpha is 1.89 radians when we've rounded it to 2 decimal places. What we then want is we want the r. And again, the r is looking at these coefficients here, squaring them under a square root. So in this case, r equals a square root of 15 squared plus the negative 5 squared. So 15 squared plus negative 5 squared, 15 squared, 225, negative 5 squared is 25, so 225 plus 25 is the square root of 250. We can simplify that down to 5 root 10, leaving it in a third form. What we can then say is fine, our 15 sin theta, take away 5 cos theta, can be written as 5 root 10, so r cos of theta minus alpha, which is 1.89. Now we have to start looking at the minimum and the maximum values. And to do that, you focus on just this part here. Focus on just the wave equation. Now we know that theta minus 101.89 shifts it in the x direction. It doesn't shift the magnitude of it, it just shifts it left or right in the x direction. It doesn't change the maximum or minimum values for the cosine function itself. Now the maximum and minimum values for cosine are 1 and negative 1. So that isn't going to change. So our maximum and minimum values of this, for the maximum it's going to be the 5 root 10 times the maximum here, which is 1. And for the minimum, it's going to be the 5 root 10 times the minimum value here, which is negative 1. So we know for our maximum, it's going to equal 5 root 10. And we know our minimum in this case is going to equal negative 5 root 10. So we know the maximum and minimum values. Once we get it in this form with just one trig function, it's actually quite easy to do, purely because the maximum and minimum values of that are fairly easy to get. Let's look at the second example now. So express 25 cos x plus 25 sin x in this form, where r is bigger than 0, and again our alpha is between 0 and 2 pi, so it's radians. Then find the maximum and minimum value of this. So again, our first step has to be expressing this in wave form, using this. So expand the k sin x plus alpha, we get k cos alpha sin x plus k sin alpha cos x. And we can equate that to this bit here. So we can equate the k sin alpha and the k cos alpha to our two coefficients here. And doing that, we get that k sine alpha is 25 and k cos alpha is also 25. And using both of these, we know tan alpha is sine over cos, so it's 25 over 25. It's just 1. Now, all three of them are positive, so we do the cast diagram. What we're able to do is tick the A box for all three of them, so we know it's going to be in the first quadrant here. So essentially, all we need to do is tan minus 1 of 1. We do that, and we get our answer. So tan minus 1 of 1 is 45 degrees, but we have to make sure we're working in radians here. 45 degrees in radians is pi over 4. We then look to find the k. Now we know k is equal to the square root of our coefficients squared, added together, so it's the square root of 25 squared plus 25 squared, which in this case is equal to the square root, well, 25 squared, 625. Add them together and you get 1250, which can be simplified down to 25 root 2. So we've got our answer there for what k is. We can then say fine, so the 25 cos x plus 25 sine x, we can write that as 25 root 2 sine of x plus pi over 4. So we can write it in that form there. Now that we've got it like that, we can look at this part here. So hence find the maximum minimum value of this. Remember the word hence means use what you've just done. Take what you've just done and show me how it can work. Well, we know that for this bit here, we can substitute in this expression. We now know that this is what it is, and this will give us it in terms of one single trig function, which will make our lives a heck of a lot easier. So we then know it becomes 100 plus 25 root 2 sine of x plus pi by 4. So now that we've got that, it's the maximum minimum part. Now this is the only thing that changes, so this is the part we focus on. But it's the sine of something. Now we know sine's maximum is 1, and the minimum is -1. So again, it's just substituting those in there. So we know for the maximum, we're going to get that 100 plus the 25 root 2 times 1. And for the minimum, we're going to get that 100 plus 25 root 2 times -1. Now if we were to do the first part, the maximum, 100 plus 25 root 2, we'd get 135.36 to 2 decimal places, and the minimum, we get 64.64 to 2 decimal places. Calculating the maximum minimum values of these is easy. The key thing is putting something that's a combination of the two trig functions into one, because using one we can calculate the maximum very, very quickly, efficiently and straightforward. Hope that went well. I will see you in class.